So 4.3 deals with angle relationships in triangles. Our first theorem we're going to look at is the triangle sum theorem. The sum of the angle measures of a triangle is 180. So how many angles are in a triangle? How many angles are in a triangle? Three. So we have angle A, angle B, and angle C. So if we add them all together, angle A plus angle B plus angle C, it's equal to 180 degrees. An auxiliary line is a line that is added to a figure to aid in a proof. So in this picture, L is not part of the triangle, but it's an auxiliary line, so it was added to help in the triangle sum theorem. So our first example, after an accident, the positions of cars are measured by law enforcement to investigate the collision. Use the diagram drawn from the information collection to find the measure of angle XYZ. So we're looking at angle XYZ now. So how do we find what this measure is?
Add 60 to 40 and then subtract that or subtract.
Right, so if we add all the angles together and we set it equal to 180. So 62 plus 40 plus angle XYZ is equal to 180. So here we have 102, so we subtract 102 from both sides. So angle XYZ is equal to 78 degrees. So our next example, use the diagram to find the measure of angle MJK. So we're looking for this angle here, the one with the star, MJK. What can we do to find that angle? Add what? Florencia?
Is it 88 plus 48 and then since it's congruent?
Right, so we can find this angle first because it's congruent to this other angle. So then we could find our angle MJK. So let's find MKN first. So we add 88 plus 48 plus MKN is equal to 180. So 88 plus 48 is 136. So if we subtract 136 from both sides, we get angle MKN is equal to 44. So this angle here is 44. So now angle JMK, this one down here, is also 44. So now we have two angles of this triangle and we can find the third. So we would add 44 plus 104 plus MJK is equal to 180. So we get 148. Subtract 148 from both sides. Angle MJK is equal to what's 180 minus 148? 32. So MJK is equal to 32 degrees. So a corollary is a theorem whose proof follows directly from another theorem. In 4.3, we have two corollaries. The first one is the acute angles of a right triangle are complementary. So if we look at this triangle, we have two acute angles, angle D and angle E. So angle D and angle E, can you guys see yellow there? Not really. I'll make it black. Angle D and angle E are complementary. What does it mean to be complementary? They add to 90. So now we know angle D plus angle E is equal to 90 degrees. So if you have a right triangle, the two acute angles add up to 90 degrees. Our next corollary states that the measure of each angle of an equiangular triangle is 60 degrees. So what does it mean to be equiangular? Equal angles. So in this triangle, it has three equal angles. So all of them are going to be 60 degrees. So angle A is equal to 60, angle B is equal to 60, and angle C is equal to 60. So if you have an equiangular triangle, all the angles are going to be 60 degrees. So example 3, one of the acute angles in a right triangle measure 2x. What is the measure of the other acute angle? So we have a right triangle, and we're going to call it triangle ABC. So one of the acute angles is 2x, and we have to find the other acute angle. So now we're looking for angle C. How do we find angle C? What equation do we need to set up? We know that the two acute angles add up to 90. So if we add angle C and angle B, we get 90. So let's angle C plus angle B is equal to 90. We know what angle B is here. What is it? 2x. So angle C plus 2x is equal to 90. So now we can just subtract 2x from both sides, and we get angle C is equal to 90 minus 2x. The measure of one of the acute angles in a right triangle is 63.7 degrees. What is the measure of the other acute angle? So again, we have a right triangle, and we can call this one ABC again. one of the angles is 63.7. And we need to find the other angle, angle C. So we know if we add the two acute angles, they equal 90. So angle B plus angle C is equal to 90. What do we know that angle B is equal to? 63.7 plus angle C is equal to 90. So how do we get angle C all by itself? Subtract 63.7 from both sides. So we get angle C is equal to 26.3.
Oh, okay, I did it wrong.
26.3 degrees. That's our answer. Let's look at example 5. The measure of one of the acute angles in a right triangle is x. What is the measure of the other acute angle? We do the same thing. We have a right triangle. We can call it ABC again. And B has a measure of x. So how do we find angle C? Plug in what? What do we know about angle C and angle B? They equal 90. So angle C plus angle B is equal to 90. So angle B is equal to the x. So we can just plug that in. So then subtract x from both sides. And we get angle C is equal to 90 minus x. Next we have interior versus exterior. The interior is the set of all points inside the figure. So our interior is going to be everything inside the figure. So inside the triangle is our interior. And the exterior is the set of all points outside the figure. So outside is going to be our exterior. So what angle here do we have on the exterior? What angle's in blue? 4. So 4 is on the exterior, and what angles do we have on the interior? 1, 2, and 3. The interior angles are formed by two sides of the triangle. So if we take one side here and another side here, it forms the interior angle. The exterior angle is formed by one side of the triangle and an extension of an adjacent side. So if we take one side of the triangle and an extension of the side right next to it, we get the exterior angle. Each exterior angle has two remote interior angles. Each exterior angle has two remote interior angles. A remote interior angle is an interior angle that is not adjacent to the exterior angle. What does it mean to be adjacent? Next to. So in this picture, what angle is adjacent to angle 4? 3. So the two angles that are not 3 are which ones? 1 and 2. So angle 1 and angle 2 are the remote interior angles of angle 4. Now we have the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So what did we say the remote interior angles of angle 4 are?
1, 2, 3.
What are the remote interior angles? So the ones not adjacent to it. 1 and 2. So the measure of an exterior angle, which is angle 4, is equal to the sum of the measures of its remote interior angles. So what does the sum mean? Addition. So angle 4 is equal to angle 1 plus angle 2. So if we add the two remote interior angles, we get the outside angle. So angle 1 plus angle 2 is equal to angle 4. So now let's do an example. Find the measure of angle B. What equation do we need to set up to find the measure of angle B? Yes.
2x plus 3 equals 5x minus 60.
Well, we need to add the two remote interior angles. So you got one of them. What's the other one we need to add?
15.
So 15 plus 2x plus 3 is equal to
90. Or 5x.
5x minus 60. So it's equal to the outside angle. So now we solve for x. So we can subtract 2 from both sides. Subtract 2x. And we can add 60. So we get 78 is equal to 3x. Now we can divide by 3. And we get x is equal to what? 26. Is that our answer? No. What do we need to plug this into? 2x plus 3. So it's asking us to solve for b. So we need to take what we found for x and plug it into our equation for b. So angle B is equal to 2x plus 3. So 2 times x, which we know is 26, plus 3. And we get, what's 2 times 26? 52 plus 3? 55 degrees. So angle B is equal to 55 degrees. Let's do another example. Find the measure of angle ACD. So we have angle ACD. What equation do we need to set up to find this angle?
2x plus 1 plus 90.
Right, so 2z plus 1 plus 90, because the other remote interior angle is 90, is equal to 6z minus 9. Perfect. So we can subtract 2z from both sides. And we can add 9. So we get 100 is equal to 4z. So now if we divide by 4, what do we get for z? 25 is equal to z. So now what do we do with this 25? Plug it in. What do we plug it into? 6z minus 9. So we have 6 times 25 minus 9. What do we get? 6 times 25 is 150 minus 9, 141 degrees. So angle ACD is 141 degrees. Okay, our last theorem in this section is the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. So if we have angle L is congruent to angle R in our second triangle, and angle M is congruent to angle S in our second triangle, therefore angle N is congruent to angle T in our second triangle. So here we have N is congruent to T. So if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. Let's find the measure of angle K and the measure of angle J. So in these two triangles, we have G is congruent to H and F is congruent to I, so therefore K is congruent to J. So what equation can we set up here? So 4y squared is equal to 6y squared minus 40. So we just set these two equal to each other. We know that they're congruent, so we can set them equal. So now we can subtract 6y squared from both sides. We get minus 2y squared is equal to negative 40. So now you can just divide by negative 2. And we get y squared is equal to 20. Can we just leave it like that, or do we have to solve for y? We can leave it, because in our equation that we're going to plug this back into, it says y squared. So we can just plug in what we found for y squared into y squared. So to find angle K, we would multiply 4 times 20. What's 4 times 20? 80 degrees. And then to find angle J, we plug in 20 for y squared, so angle J is equal to 6 times 20 minus 40, which is 80. We know that they're congruent, so good thing we got the same thing. Okay, last example. find the measure of angle P and the measure of angle T. So here we have two sides of the triangle that are congruent, two angles of the triangle that are congruent. So what do we know about the remaining third angles? They're congruent. So what can we do in our equation? 2x squared is equal to 4x squared minus 32. And now we do the same thing and we solve for x squared. So we can subtract 4x squared from both sides. So we get negative 2x squared is equal to negative 32. And then we divide by negative 2. And we get x squared is equal to, what do we get for x squared? 16. So now we just take what we found for x squared and plug it in for x squared. So for angle P, two times 16, which is 32. And for angle T, we do 4 times 16 minus 32, which is also 32. So angle P and angle T are both 32 degrees. So that is everything for 4.3.